Imagine standing on the edge of an ancient ocean millions of years ago. Everything appears peaceful. The water is warm. Sunlight shines across the waves. Beneath the surface, countless creatures move through a world that seems almost endless. But far below them, something has already begun to change. The deeper ocean is slowly losing oxygen. At first, the change is almost invisible. Some animals move toward shallower water. Others disappear from the deeper regions. Nobody or nothing understands what is happening. Then the dead organisms begin to sink. Their bodies become food for microscopic organisms living in the water, and these microbes need oxygen. They consume it as they break down the dead material. The more organisms that die, the more food sinks. The more food sinks, the more oxygen the microbes consume. And slowly, an enormous cycle begins. The ocean is feeding the process that is suffocating it. The deeper water becomes increasingly hostile. Animals that normally live there begin disappearing. But why was there so much dead material in the first place? Scientists believe that major changes in Earth's climate and ocean circulation could have triggered enormous increases in nutrients reaching surface waters. Those nutrients fueled massive blooms of microscopic life. For a while, it looked like the ocean was becoming more productive than ever. But there was a hidden price. When those organisms died, their remains sank into deeper water. And as they decomposed, oxygen disappeared. Eventually, parts of the ocean became oxygen-poor zones. And then something even more disturbing could happen. When oxygen becomes extremely scarce, microorganisms can use other chemical processes to survive. The chemistry of the water begins changing. Toxic compounds can form. The ocean becomes not only difficult to breathe in, but chemically dangerous. Imagine being a fish millions of years ago. You swim deeper to escape the heat. But the deeper you go, the less oxygen there is. You turn around. You swim toward the surface. But the conditions above are changing too. You are trapped between two dangerous worlds. And this wasn't necessarily happening in one small area. During some periods of Earth's history, enormous regions of the ocean became oxygen-depleted. Scientists call these episodes oceanic anoxic events, and they may have contributed to some of the major biological crises in Earth's past. But here's the most frightening part. The ocean didn't suddenly lose its oxygen overnight. It was a chain reaction. Heat changed the ocean. The changing ocean changed its circulation. Nutrients fueled enormous blooms. The blooms died. Their remains sank. Microbes consumed the oxygen. And eventually, the ocean began suffocating itself. But this raises a much bigger question. If Earth's oceans have lost oxygen before, could the same chain reaction happen again? And if it did, how much oxygen would the ocean have to lose before marine life began facing a global crisis? The answer takes us from the ancient ocean to the ocean beneath our feet today. For millions of years, Earth has experienced dramatic changes. Ice ages came and went. Continents moved. Volcanoes erupted. Oceans warmed and cooled. And through it all, the ocean remained one of Earth's greatest life support systems. But today, scientists are watching something unsettling. Oxygen is disappearing from parts of the ocean. Not everywhere, not all at once, but enough to matter. One reason is rising ocean temperature. Warm water generally holds less dissolved oxygen than cold water. As the ocean warms, it becomes harder for oxygen to remain dissolved in the water. But temperature isn't the whole story. Human activity adds another piece to the puzzle. Fertilizers and nutrients can wash from farms and cities into rivers, eventually reaching coastal waters. These nutrients can trigger enormous algae blooms. At first, it looks like an explosion of life. But when the algae die, their remains sink. Bacteria begin decomposing them. And once again, oxygen gets consumed. The result can be what scientists call a dead zone, an area where oxygen levels become so low that many animals cannot survive. Fish can swim away. But creatures living on the seafloor have a much harder choice. They may have nowhere to go. And if oxygen levels fall extremely low, entire communities can collapse. But there is an important difference between today's oxygen-depleted zones and the enormous anoxic events of Earth's distant past. Today's dead zones are often regional, especially near heavily nutrient-polluted coastlines. Ancient oceanic anoxic events were vastly larger and were driven by major changes in Earth's climate and ocean system. So, should we expect another global ocean catastrophe tomorrow? No. The ancient events happened under conditions very different from today's world. But the ancient oceans give scientists something incredibly valuable, a warning written in Earth's geological history. They show us that ocean chemistry can change dramatically when climate, circulation, nutrients, and biology interact. And there's another fascinating clue. When oxygen disappears from the ocean, the seafloor can preserve evidence of what happened. Layers of ancient sediment can contain unusually high amounts of organic carbon and other chemical signatures. Millions of years later, scientists can examine those layers and reconstruct the story. They can see evidence of oceans that once became dramatically different from the ones we know today. So the ocean has a memory. It remembers ancient disasters, even when every creature that witnessed them has been gone for millions of years. And perhaps the biggest lesson isn't that the ocean is suddenly going to disappear. It's that Earth's systems are connected. A change in temperature can alter circulation. Circulation can change nutrient distribution. Nutrients can change biological activity. Biological activity can change oxygen. And oxygen can determine which creatures live and which creatures disappear. The ancient ocean once crossed that dangerous line. Life survived, but not every species did. And today, scientists continue watching oxygen levels carefully, not because they expect another ancient catastrophe tomorrow, but because understanding how oceans respond to change can help us recognize danger before it becomes irreversible. The ocean has survived some of the most extreme transformations in Earth's history. But every layer of ancient rock tells the same powerful story. The ocean can change, and when it does, life changes with it.